Good evening to all the school teachers participating in this SETU program. The topic of today's discussion, which we are going to do, is search of life beyond. When we see a image from James Webb of part of the universe, what we see thousands of stars and galaxies. So naturally, it comes a question to us that whether are we alone in the universe or there are other planets where similar life patterns like Earth also exist. It's a very natural quest. So, we start this discussion today, and we all know that life first emerged on Earth more than 300 billion years ago. It was just less than 700 to 800 million years after the formation of planet itself. Planetary evolution over the 6 decades has covered most of the planetary bodies in at least solar system. We have reached and taken up majority of observations in solar system. But by now, there is no concrete evidences of life being found in any of these planets. So the question comes, the principle of physics and chemistry are universal. We see that plants are evolving, we see their gaseous composition. So physics and chemistry laws are very, I would say, universal on Earth and other planetary systems. It would therefore seem surprising that if biology was specific to planet Earth, so why this particular life which only exists on Earth and not been discovered by now in other planets, although there are indications about them. So we are going to deal this particular question in this particular lecture. So when we see planetary objects in our solar system or even beyond it, galaxies, when we observe from our ground-based telescope, there are a lot of attenuation of atmosphere. That is why space stations, space-based systems are preferred, like in this particular image which you are seeing. If I have to see the Saturn, we can see very clearly from space missions like Spitzer, Hubble, or James Webb. But from ground, there are some attenuation. That is why the space systems are preferred. While doing various missions, there are various type of missions one plans for, depending on the kind of objective of the mission. I mean, there are flybys, there are rovers, orbiters, landers, balloon, parachute. There are so many, depending on what kind of research we are doing. If you see the different probes sent to various solar system objects and the bodies, you'll find that Earth's moon is the most explored. Like it has explored by flybys, orbiter, probes, lander, rovers, sample return, even human has gone. So the Earth's moon is most explored, and besides that, then Mars and Venus, where there again many missions has gone. Before we come to our talk on the life beyond Earth, let us see how many missions, major missions, which has been gone to search for life or doing planetary explorations. So things started in 1959 by Luna mission, and it was a sequence of Luna. Then Mariner mission, Apollo mission, Pioneer, Voyager, Galileo, Cassini, Messenger, Mars Reconnaissance Orbiter, Venus Express, New Horizon, Juno. These are some of the major, what we call planetary missions, which have gone to different planetary bodies. So let's talk about how we'll find the life beyond the Earth. So it says that life only exists in certain habitable zone. How one defines habitable zone? It's a concept of habitable zone refers to distance from the parental star where Earth-like habitable situation more conducive for life exists. Like if any planet is close to its star. It will be too hot. And obviously, if you're too hot, life possibilities are very rare. If you are too far from your star, any planet being quite far away, like our Jupiter, Neptune, they're too cold. So if you're too cold, obviously life won't exist there. So if you are just rightly placed in form of distance from the star, like Earth, there you have a sufficient temperature and atmospheric composition, and life would form. So it is a zone where this conducive environment of temperature and atmospheric compositions exist, which is a function of the star as well as the planet at and distance of the planet. If you see the habitable zone, obviously, if the mass of stellar body or the star is high, the zone exists at certain what do you call larger distances to have that condition environment. If the mass of stellar object is little, it is less brighter, it it may happen that the favorable zone is closer to relatively closer, I would say. And for example, in our solar planet, the distance is such that our Earth lie in the habitable zone. With fringe, in the fringe, Mars and Venus are there, where some possibility of life exists. Otherwise, Mercury is too hot, and Jupiter, Saturn, other planets are too cold. Say, so they do not lie in habitable zone. In fact, this, as I said, is a function of the stellar mass or size. Like there is a TRAPPIST system, similar like solar system. That this system, the star is smaller in size and lesser bright. It has been found, although it has 7 planets into it, it has been found the habitable zone lies much, much closer than it lies on the solar system. If you see this view graph, a habitable zone planet even is a nearer, even less distance from Sun as compared to Mercury. It's because its star is like this. So habitable zone is a function of the type of star and the distance of the planet, which is lying in rotating the particular star. So that's why we are, I would say, fortunate that Earth has this lies in habitable zone in solar system, and that's how the life has emerged into it. That's the basic explanation. And if you see the evolution of life on Earth, you'll find that it started all with bacteria, then eukaryotes, then plants, fungi, fishes, amphibians, reptiles, birds, mammals. In fact, humans are the rather recent occurrence, only 6 million years ago in the history of billion years. Okay? And it is also said that bacteria hold far more genetic diversity and account far more biomass than any plant and animal do. This is what the basic life cycle on the earth. First of all, question comes, how do I define a life? So, in formal sense, life is a self-sustaining process which undergo metabolism, growth, reproduction, and adapt to the environment in successive generation. The diversity of life is a result of dynamic interplay between the genetic opportunity, metabolic capability, environmental changes, and symbiosis. That is why I see so many diversity, so many type of animal and plant system. How they come about? They come because of dynamic interplay between a lot of environmental conditions and genetic opportunity, which has evolved over the time. What are the necessary physical and chemical factors to have life exist? Obviously, energy is the first factor. Generally, it is sunlight, what we think which is responsible for it, but it can be a chemical energy too. Environment is another variable which we need, a conducive environment, which includes water, nutrient, temperature particular atmospheric composition. And even if you have energy, even you have an environment, but your planet is not protected the way Earth is protected from UV radiation and the cosmic radiations, life won't exist. To life exist on the planet, apart from you have sufficient energy and conducive environment, it should be radiation protection. So, what is the basis on which this energy comes? The energy in our Earth is mainly from photosynthesis. There is conversion of the light into organic matter. But it has been found that many of the cases, they are chemosynthesis, which is also responsible for the what you call energy in this life form. Like we have extreme diversity. Do you know there are hydrothermal vents at the bottom of the ocean, and there traces of life exist. How it can happen when light cannot penetrate to that depth level of ocean? Obviously, there would be some other form of energy, maybe chemosynthesis or other kind of thermal energy being there. Generally, we think the molecular basis of life is carbon and water based. We should have C and H2O in a material to have the life form. Our understanding of the Earth is. But in many debates, is find that not necessarily it is carbon-based life. If some planetary system or star system in some galaxy, even if it is it can be silicon-based. This is just a research and hypothesis because people think a lot of commonality of silicon and carbon exists. So we should not be totally biased with the life form. It has to happen the way it has happened on Earth. There can be other material too. And that is the area where the investigation needed more. Let's talk about the photosynthesis. It is taught in our schools and it is fundamental to life on the earth because this is the only source by which energy of the sun get converted into the organic matter. Of course, it happens in leaf in the presence of chlorophyll. So, it is a process in which carbon dioxide plus H2O, when they are together in presence of sun energy within the chlorophyll, you need a what you call this leaf or the plant system. It get converted into sugar C6H12O6 and oxygen. So the process in which carbon dioxide and water get converted into sugar or the carbohydrate in general and oxygen is known as photosynthesis. And do you know when the first photosynthesis bacteria came? This process came around 3.4 billion years ago. Later on, there was a development of cyanobacteria, and then red and brown algae, then green algae, and the process continues. So this photosynthesis is taught into school level it is so important that it forms the basic fundamental block of life on Earth because this is the only mechanism by which we trap the light and get converted into the biomass or carbohydrate, organic matter. Then a question comes. Suppose our Earth is full of photosynthesis. We use visible light to do this photosynthesis. We call photosynthesis active radiation. This range from 0.4 to 0.7 micrometer, and most of our plant look green because the photosynthesis takes place between the 0.4 to 0.7. If there is another planet, another solar system of another star, which is either brighter or even duller or smaller or bigger than our sun, will also be this color similar? Like if I could ask a question, we are able to see the visible light, not beyond it, like infrared or ultraviolet. Why? So one connection to this is that our planet, our star, the sun, which is G-type star, which has a 6,000 degree Kelvin temperature, if you compute its peak emission from Planck radiation law, you'll find that peak emission lies in visible region, and that too on a green region that is called 0.583 micrometer. So it might be that all our plant system are adapted to this. Even we have adapted to our parent sun. That's why we see invisible region. Suppose there is another star called F type or some other type whose energy is higher. Let me take F type. So F type are generally 7,500 Kelvin temperature. So if the temperature of the star increases, its peak emission shifts toward the lower wavelengths. So if it is F type, the peak would be around blue, 0.451 micrometer. So what does it mean? The plant or animal or whatever life form would have been there would have been blue color. Just it is a hypothesis. So it might be possible. It might be possible that life evolves around the peak emission of the star. And peak emission of star is a function of temperature, and all these stars, this function of temperature and its brightness are linked together. More the temperature, brighter they are. Lesser the temperatures, the absolute magnitude is less. There is a broad pattern into it. So depending on the type of star, a life would involve in a similar conditions. So the green color what we see is due to the solar radiation being emitted maximally in the green color. Even if we have energy, nutrient, water is equally important. And to have water in liquid form or solid form or vapor form, this water exists in three forms. And it is the earth only where the temperature pressure condition are such that we have all the three forms: solid, liquid, and gaseous form or vapor form. If you go to Mars, it is cooler and the pressure is low. Its atmosphere is quite thin. So what happens? You cannot have a liquid because it does not lie into the zone, because the solid, liquid, and vapor phases depends upon the temperature and the pressure. So Mars will not have a liquid water because its pressure is too low and temperature is too low. Similarly, Venus, temperature is very high, pressure is also very high. So we have vapor system. We will not have a liquid water there too. So we are lucky that Earth has this temperature pressure variation to such that the water exists all the three forms, and that becomes the basic conducive factor of having life. So what we are learning that the life on Earth has happened because of various regions, which includes the energy availability as well as the proper atmospheric condition in terms of temperature, pressure, and composition. To hunt the life beyond Earth, those planets which supposed to have life pattern, they are called exoplanets. A Kepler mission was launched in 2009 to discover Earth-like planet orbiting other stars. And they have detected many, what you call exoplanets, which include hot Jupiter type super Earth planet located in a circumstellar habitable zone of their hot star. So this particular mission gave very informative knowledge about the possibility of life in some of their planets called exoplanets. What method they use to know any star as any exoplanet where life can exist? One of the methods is called transit method of detecting extrasolar planets. What this method says, when a planet crosses in front of a star as viewed by the observer, through a telescope of Kepler, or you can devise any instrument on the ground also. The event is called transit. Whenever the planet will cross the sun, there will be a dip into the star brightness. Generally, this dip is very, very small. 1 upon 10,000 could be of that night. So, if our instrument is able to get that dip, it means there is some planet revolving around that particular star. So, this method is called transit method, and Kepler used to work on this principle. Recently, you know that James Webb Telescope is also doing a lot of research, particularly also they are looking at the exoplanets. And researchers confirmed an exoplanet that orbit another star using James Webb recently. And you can see the same principle here, that while watching that particular star in an IR spectrometer, James Webb relative brightness suddenly becomes lesser when there was a transit of planet, and you can see the observation as well as the model to do that. So they have detected using this principle many exoplanets. By now, it is said that around more than 5,000 confirmed exoplanets has been detected by various missions, which include Neptune-like, gas giant, super Earth, terrestrial, and something like that. And just to inform you that in 2024 only, there was a discovery of UCAC3, which is a giant exoplanet that orbits M type of star. Its mass is 21 times Jupiter. So this discovery of exoplanet where possibility of life exists continues to grow. So in ISRO also, the ISRO is one of the unit physical research laboratory, use advanced radial velocity Abu sky search called Paras spectrograph. This spectrograph is there. It is 1.2 telescope, 1.2 meter telescope up at Mount Abu, and they detected also from the Mount Abu itself, from the ground, a exoplanet. And this planet is about 27 times Earth mass and size of a 6 Earth radii, around 600 light years away. And they used the radial velocity technique, in which if the star is of relatively less mass, its relative velocity with respect to observer, due to that movement of this planet, changes, and that gives a shifting, what you call a Doppler shift in their spectral emission, and that techniques are used to know the exoplanets. So ISRO's PR laboratory has also found one of the exoplanet. How do I know that exoplanet I am detecting would have a life? What are the biosignatures? So literature says that if you are able to detect oxygen or water, ozone, methane, or it's some seasonal cycle, methyl chloride, nitrous oxide, then there is a chance that there are biogenic factors, because many times these kind of gases composition are because of some life form in either bacterial form or some other form. It happens. But remember, it's not always. Even there can be abiotic sources for these gases also. But they are one of the indicators of life on any particular planet. How do you know such gases exist there or not? So it all depends on how you do this detection, and the one principle is called spectroscopy. So what you have? You have a very high resolution, what you call a spectrometer, where the light can be splitted into a very small, what you call wavelength slices, and these gases of oxygen, ozone, methane, they have a what you call a spectral feature that they absorb certain wavelengths. So when you look the particular atmosphere of this planet or the star, you will find that some wavelengths you are not getting energy; they are getting absorbed. So a spectrometer will detect. And physics-wise, it is known that which molecule will absorb at what wavelength. So looking at those absorptions, scientists are able to know that the particular atmosphere of a planet consists of which kind of gas. For example, you see this curve below. When James Webb saw the Martian atmosphere in 1.0 to what you call 5.0 micrometer range, we call NIR spectrum of that module, you see that a lot of dips and ups into it. And this dips and ups at certain wavelength was because of carbon dioxide, carbon monoxide, water, and this is the principle by which these gases are detected. So, how do I find exoplanet? One is that let us study our Earth also, as Earth is also a planet where life exists. So, if I observe Earth from a very distance as a disk integrated spectrum, how it would look like. So, if you generate the spectrum of this kind nature, obviously any planet having similar kind of spectrum, we can say that is like Earth, and possibility of light exists. That is the one approach. So you can see that in the visible, the infrared, and thermal infrared. Measurements were taken from Cornell, Massachusetts spectrograph, NASA's extrasolar planet observation, or Mars Global Surveyor en route to Mars. When it was going, it took those measurements. So these measurements are now available. So these spectrums are one of the reference spectrum that if any planetary system has this kind of variations, probably it has that possibility of life there. This is one of the approach. People also try to find the sources of life across using radio telescope. The project or the program is called Search of Extraterrestrial Intelligence SETI. What one does is one investigation of cosmos using large radio telescope. There are big antennas in which you see in a radio waves, and way of discovering an artificial extraterrestrial civilization to detect the artificial radio emission from local location outside solar system. Here we believe that if at all any intelligence system exists outside, extraterrestrial civilization, they must be giving some artificial radio emissions. By detecting them, we can know them that some intelligence species exist there. And this kind of concept is called SETI, and people continuously try to observe it. By now, still people has not got any such kind of signal, but research continues and observations continues. This is the one way by which we can detect it. There is theoretical principle called Drake equation to search the extraterrestrial intelligence. So the Drake equation suggests the number of civilization in our galaxy with which is communicating might be possible. Suppose it is n. So we can compute it by knowing theoretically the average rate of star formation per year in our galaxy, the fraction of those stars that have planets, the average number of planets that can potentially support life per star, the fraction of the above that actually go on to develop life at same point, fraction of the above that actually go to develop the intelligence life, fraction of civilization that develop a technology that releases detectable signs of their existence in space, and length of time by which such civilization release detectable signal. So if I know, or if I assume all these parameters, I can compute n. But obviously, theoretically also, this n is supposed to be very less, even 0 or very small number, because having probability of all these things is a very difficult task. That's why by now, it has not been detected, but people continue doing. So the number also would be little, because it requires so many assumptions to exist there to have a extraterrestrial signal, intelligence signal to us. So besides going to the larger galaxies and distant galaxies, one has to find the possibility of life in our solar system. So as I said, Exactly, Earth is there in habitable zone, but Mars is also in the fringe because of size and composition. It has atmosphere, and our earlier proofs suggest that although Jupiter and Saturn are not in habitable zone as per our definition, they are colder planets, but their moons have a probability of having life there. So generally it's said that Mars is one of the important place where life would exist, if not on surface, the subsurface processes. Io on Jupiter's moon also supposed to have a complex chemical promising for life. Europa, another Jupiter's moon, although it is frozen surface, but supposed to have chances having life. Titan, the Saturn's moon, is very similar like Earth in size, and there's a high chance that it can have life because a methane has been found on there. And Encelad, Saturn's moon, also has a possibility. So these are some hotspot areas where further researches are being done to probe those areas where we can get the life. Mars Orbiter mission, I hope many of you must be aware that India launched this mission in 2013. And the 5th November 2013, this mission was launched and it reached there on 24 September 2014. So, and we were able to get a lot of pictures of Mars. You can see in this picture, Olympus Mons is the highest mountain, volcanic mountains in solar system, around 24-kilometer height. So it has many features having fluvial processes and everything. And it says that not now, but sometime back, it might have been a wet system with possibility of life there. While analyzing this Mars orbiter mission pictures, we found that there are fluvial patterns. There are many fluvial patterns. One place called Mangal Valley, we found that there's a rupture in the surface itself, the fault system, and there a huge plume of water has flown there. And that happened because there was an ancient mega flood where the surface got ruptured, and beneath the surface there was a huge water which came out. Because here you are not finding that any snow peaks or that kind of patterns are there. The water is being emitted by a rupture. So it suggests that even if water is not available on the surface, there is a high chance that water is there inside it. So there's one of the indication that subsurface processes might be existing, and there are chance of life. That's what it shows. So, and we found that there was a huge outflow of water in Mangla Valley in ancient time. The signatures were seen from Mars color camera. We also seen that in Mars there are so many places we call recurring slope lineae, a gully-like feature in some part of the craters, and it seems that some liquid kind of thing is flowing down. Although, as we discussed, that in this low pressure condition, liquid cannot be there. So there are some hypotheses that it might be a water mixing with percolates, what you call brine water. So if there is salinity or the brine component to it, might be that the conditions in this even low pressure condition and things also it can form in liquid way. But this is what the hypothesis is, and work is going on that what was flowing there. But there are certain indications. There was a radar placed in one of the satellites, and from radar it was found that there is a liquid water content beneath 15 kilometer of the surface. That was found. So that hypothesis that underground water do exist. The radar observations say so. And that gives a promise of us that if not on surface, subsurface, some processes might be happening. That's why we need very much more researches on that line. And this get also substantiated by the fact that the Curiosity rover, which has a specific instrument called TLS, a tunable laser spectrometer, which has the ability to detect methane in a very, very even a less amount is there. What they found, although the methane in the Mars is now very little, in ppb it is there, zero point 0.4, zero point 0.6, but their observations suggest that there is seasonal cycle. Like in some season, particularly summer and autumn, the amount is more relatively as compared to spring and winter. And when there are seasonal cycle, there is a likelihood that there can be biogenic influences of bacteria or something like that. So that need further investigation. But again, it gives some indication there can be subsurface processes by which methane is getting emitted. Although methane do get emitted from the geological processes too. So I was talking about apart from Mars, we have to hunt the life features in other planets also. So Jupiter, Saturn, as I said, are the one of the locations, but they're moons. So particularly Io and Europa and Enceladus and Titan. There are few moons of Jupiter and Saturn. And why we think a light would be there? Because of they have a hydrothermal vent, the plumes. You see a lot of plumes coming out of them. Some of them have liquid methane, cryo geysers, cryovolcanic processes, subsurface liquid water, tidal flexing. Even there is a possibility that that could be radioactive heating beneath the surfaces. That's what these things are happening up. Otherwise, how such processes do take place? So if you see the Io of Jupiter, it shows it has a dense active volcano and plumes of sulfur and SO2. The picture was taken by New Horizon while passing Jupiter flyby, and it suggests that plumes could show that there is subsurface processes which can provide that life support. Europa is another Jupiter's moon I was talking, which is frozen basically, and it has a water ice surface, thin atmosphere, some streaks are seen, and it also has plumes of water vapor. Like you see cycloid ridges on Europa. And it's thought that its surface moves faster than subsurface ocean. There is a chance of subsurface ocean inside. And since they move differently, these patterns get generated. There's something called tidal flexing happens. So there is subsurface liquid water there. And there is chance that radioactive heating also is there. That's why this moon of Jupiter can have a life supporting elements. People have seen a huge plume coming out of it, and that can only happen when the internal source from the decay, and this also leads to one of the quests that it should be proven further to find more details what is there in Europa. If I talk about Saturn's moon Titan, it is one of the most probable place where life can happen because it has a dense atmosphere, liquid surface, ammonia-rich liquid water subsurface, and Cassini radar has seen a methane sea near Titan's north pole. So whenever there is a methane, I mean, since it is associated with life-bearing molecules also, I mean, there is chance that this Titan also has the sources of conditions conducive for life. And another evidence is that when Titan was seen through hygiene lander, you will see the pebble kind of patterns are there, which is there in Earth rivers also, rocky, I mean, these patterns. So this talks about the fluvial kind of patterns. So whenever there's a fluvial pattern and all those things, that leads to those hypotheses. Enceladus, as I said, Saturn's moon, the moon also shows a lot of multiple jets dominated by water vapor and ice particle containing rich mixture of other compound, fresh and clean ice, subsurface liquid water possibility exists. And a thermal emission in part of something, a place was also seen from Cassini in the wavelength of 9 to 16 micrometer, shows that it has some internal energy and which can give support to life. Besides such kind of observations, detection of polycyclic aromatic hydrocarbon, we call PAH, is also one of the method by which you see galaxies. And this pH are powerful tool for exploring the building block necessary for origin of life in star and galaxies. And this pH fluorescence in the infrared region 6 to 8 micrometer. So wherever abundance is there, I mean, it is also said to have provide the conduciveness of the life. People have seen from Spitzer satellite at its emission in 3.3, 6.2, 7.7, 8.6, 11.3, and 12.7 micrometer. These emissions suggesting the pH existing there. Now, when we detect anything on a planet, as I said, either we detect methane, either we detect any other biosignatures. How do I call it? Is it will have it is whether a biogenic origin or abiogenic origin, because geological origin can also be there. So Raman effect or spectrometer based upon Raman effect are promising tool to detect even the organic matters. And Raman scattering is important. It was discovered by Sir C.B. Raman in 1928, in which conventionally scattering, when you impinge any light, the scattered light is of same wavelength. But in Raman scattering, the scattered light also, there is shift in the frequency. And that shift is the intrinsic property of the material. That's what Raman discovered. And nowadays, a lot of instruments are being developed based on Raman principles and being employed in space mission. I would take example of a rover which has a Sherlock spectrometer, which is based upon Raman. Its name is Scanning Habitable Environment with Raman and Luminescence for Organics and Chemical. So it has a possibility of detecting the organic material also. Where all other techniques are not necessary, they can detect organic material. So for that, one has to do Raman is one of the spectrum. I mean, the technique, and this particular instrument is placed in a Perseverance rover, which is moving in a Jezero crater. Jezero crater of Mars, where the Perseverance is already taking observations, has a lot of fluvial processes, river delta, and many of such inflowing ancient river kind of patterns. And people think there would be some kind of organic material also be available. That's how this Perseverance is working on that line. And already a lot of experiment is being going on that to detect the amino acids, polycyclic aromatics, and all these things from this technique. Hopefully, with the advancements of time and technology, we will one day discover some of this life-bearing molecules of organic nature, and that's how the research is going on. Thank you very much. And this is how I wanted to share with you that what are the various techniques by which people are probing different planetary system, and the basic natural quest of humanity, that are we alone or we have a similar civilization in other planet, continues to be there. Thank you very much.